Well, good afternoon, and thank you, Forum, for giving us the opportunity to present the project to you. Colleagues will further expand on that. And we decided to present to you this project along with a 3-year work that involved our technical staff and research institute, the university, and a producer. This is an example of wine learning. What is wine learning? Let's start from the very beginning. In 2015, at Forum, we presented a project which was called Y Team, which was our quality control program. Y stood for yeast, and you see as there was also the contribution of University of Padua. And that was a project at the very basis of quality control for the development of biotechnologies at EVA for the marketing, of course, of those products. This entailed managing the production of the yeasts, the management of the recipes, quality control of the strains included in the assortment, and implementing a number of actions when it comes to the genetic part, the technological part, and the various characterizations. This is a system we set up in order to develop and evolve, not simply in terms of quality control, but in order to know about the best applications and the composition of a specific strain of yeast. After starting this, we expanded it to derivatives, and I think that yeast derivatives really have been mentioned so much recently. In general, you see, there are many, though, on the market, and with Paolo, with Italiana Biotecnologie, we saw that the fact of being able to characterize them and to actually understand what one specific derivative could bring and why, and how it could prove useful to vinification, made it possible for us to set up a quality control system which also includes nutrition and organic improving agents in order to give a high quality proposal or make a high quality proposal to the market. What does it mean? It means that we know everything about what we are offering and promising. Then we decided we needed to understand even more than that and know what the quality control model it meant for us. 3.5 million kilos of wine yeasts. 1 year of vinification in the world was done with yeasts coming from Pramaggiore. So evidently we were doing the right thing. And then yeast derivatives, it is more or less the same amount. So we want to grow also in quantitative terms and have new information about the biotechnologies we sell and that we can bring to the seller. We wanted to be esteemed in that respect by our clients. So we said to ourselves that we would continue investigating the features of our yeasts and derivatives. But we also understood that we needed to do more and understand what happens when they ferment, because the crucial part is there. Fermentation is crucial in winemaking. So we know today what happens before, we know what happens afterwards, but oftentimes we do not have a full knowledge of what happens in between. And being more knowledgeable about fermentation was therefore the goal, in order to understand beforehand what might happen. That entailed studying a predictive model back in 2019, precision and forecasting enology is what we are talking about. What is must? What is its precise composition? How much can we expand our knowledge of the must in order to forecast what happens at harvest? How does that composition change? Because yeast is always the same, and this is guaranteed, but your must changes from year to year and from day to day and from area to area. This is something which is often neglected as a variable, but I appreciate it so much what, for instance, Moyo said. He said that we should continuously research things because you see everything is kept the same and yet results change. So apparently there is something that changes because everything changes day by day. Grapes are different. And being it so, can we really think that we should use the same yeast invariably because we decided that 10 years ago when climate was different, consumers were different, and so on and so forth? Of course, the answer is not, is no. And we should have a pragmatic model. Yesterday's information is useful to foresee what will happen, but it is no longer real and applicable to today. You will never come up with two identical juices in 2 different years. It would be magic. Unfortunately, this is not something we can do, but we can foresee what happens based on a number of variables. And the variables should be better understood. A model should be developed, and wine learning comes into the picture here, starting from the wine, because wine, while fermenting, tells us about the future, and we should listen to wine. We heard a number of English-speaking, Italian-speaking, French-speaking speakers. So interpreters are also working. We all understand each other in this way, but nobody speaks the language of the yeasts. Yeasts would tell us a story. Wine would tell us what is happening, but we do not understand the language spoken. We should therefore create a common language and create a system where we can listen to the yeast while it tells us what it wants to do. And the same applies to wine. Hence this project. This started in the tasting room as wine learning entailed matching the wine to certain organoleptic features. We measure, but then, of course, tasting is key. We saw whether values correlated or not. And the same went for fermentation. Of course, things remain the same, but this year it is 100, next year is going to be 200, last year it was 50, and that goes for the compounds we know, not to mention those that we don't know. The better we parameterize all this, the better we place everything into a system, the more the knowledge that we can acquire. And now I give the floor to Paolo Antoniali, who will expand on this. Thank you. Good afternoon. I was in the previous picture with short hair. This is the effect not of climate change, but of aging, my aging, that the hair is different. I will sum up what I'm going to tell you in my presentation. Basically, we decided we would work on a highly operational predictive model for fermentation and re-fermentation with an empiric diagnostic approach, which is a pragmatic experiment. Experiment is what you need to do all the time. Without that, you can hardly make progress. This approach should be also lean, fast, early. And when you use the information that you obtain from the approach, you should be able to characterize the state of the system, grape, fermentation, and wine. in characterizing things, we should indeed identify the single components and understand interactions more than the elements of the system itself, and the added element gives a result that exceeds the single component. The idea was to identify operational strategies that would make it possible to anticipate what might happen at harvest, during fermentation, or re-fermentation. And this is summarized in a concept which is that we want to understand, we want to learn in a validated way. We need to demonstrate and consolidate progress that is obtained. That is the goal. Now, in order to do so, we started with and from a vision. In a vision, what is important is making. Acting is at the very basis of change. Unless you do so, you will never achieve anything. And we want to learn by doing. And we want to learn to teach. And acting is what is needed. The acting part, the doing part is key here. We wanted to have an ecosystem of innovation that brings together elements, that creates an ecosystem that focuses on innovation. The operational strategy for us being that we can plan experiences. This is a cycle in which we measure, learn, and plan, and so on and so forth. And in order to manage this experience, we also have to measure, be able to measure progress. Milestones must be set, priorities must be established in the tasks to be performed. Over the past years, it has been increasingly said that the context in which we work is a context that is characterized by high complexity, uncertainty, volatility, ambiguity. At the end of the day, you see the market, consumers, make progress based on the same growth engine, so to say. And we are mechanics, like the mechanics at Ferrari. We should fine-tune the components of the engine so that the machine runs smoothly and fast. We have established and fixed 4 concepts. First, innovation, which is a collective phenomenon. Innovation is a system. Innovation must be sustainable. Innovation must be the coming together of profitability and also feasibility and other conditions. Plus, we need to have a lean approach. We must be able to respond rapidly to events. Rather, we should anticipate them. And then we plan experiences. Information with experience, genesis, experience, and then if you put everything together with creativity, you obtain innovation, which is supportive, meaning that it helps you improve what is already there, or you can trigger something which is revolutionary, disruptive. The criterion that we worked at actually started from a strategic and also a more technologic scientific model. Now, features of both. We must be customer-oriented. We must work on partner experience, design thinking, open innovation, problem solving. We need to have an open mind and be open to solutions and develop ready-to-use solutions. Then multidisciplinarity is a key. It is not one vision only. The mindset should be systemic. That goes hand in hand with multidisciplinarity. Multi-homic approach, open science, big data, digitalization. We should not release into the atmosphere data, as is the case with CO2, predictive algorithms, and reframing of paradigms. We can generate new ones that will abandon the previous ones. In the case that we are going to present to you, we have a typical example of the ecosystem of innovation. Here you see Ever, Nicola, Biasi, MASUT DA RIVE, Italiana, Biotecnologie, and Padua University. We all share the same goal, which is that of designing innovative ideas and experiences. This has led to a number of programs. Pillars of the model, the We Must program. We must constantly profile musts and wines. We need to increase the level of knowledge we have on the initial matrix and the finished product. The maturation parameters are no longer enough. Sugar, pH, total acidity do not suffice, not anymore. And then fermentation, fermentation is the name of the program. We played with words a bit. It is a real-time monitoring of the kinetics of fermentation. Another program entails that we experiment together with the seller, to have a constant communication with them. We need to work in a systematic, controlled, empirical, and critical way with the sellers. Then we have a reframing. Reframing means that exploring the future, always by doing. We need to set up experiments also in situations which might seem paradoxical, and we should develop new learning methods. This is the workflow of our experiment. What we basically do is to take grapes 10 to 15 days before harvest. We analyze the features to make a profile using technology. Of course, we add chemical analytical assessments. We then classify based on the parameters given by the sellers, and we start to make fermentation tests with the pre-harvest juice. Then tests are completed. We make a sensory analysis and compare and contrast the samples, and we also perform chemical analysis for that purpose. And then we have harvest, which means that part of the juice coming from the harvested grapes comes to the laboratory, and this is also tested, and we compare and contrast it with the pre-harvest juice. And then there is fermentation in the cellar, with conditions that can be among those that were defined in the pre-harvest phase. Then end of fermentation, analysis on finished wines is made, and the data is compared and contrasted. We make more than one test, and this triggers the beginning of a cycle which is repeated, where we also create new scenarios. We try and invent future, even when that is not pleasant or when we would like to avoid it, because we should also learn from situations which are different from those that then actually occur during the harvest. And you need to profile wines. In the specific case with Sauvignon Sauvignon Blanc, we did a profiling of grass chromatography aromatic elements and compared the results for 3 years to see about the variability in terms of the components, terpenes, and so on and so forth. And we also wanted to identify whether there was a distinctive feature of the cellar, of the grapes, or of the harvest itself, so the season, the year, I mean. And acetate is normally higher in young wines and lower in aged wines, and the contrary applies to other wines. Then THiols for MMP was at the center of attention because the seller was specifically interested in that. Tasting was performed, and I'm sure that Nicola will expand on that. Now, vitamins. We focused especially on the amino acidic composition of juice pre-harvest and at harvest. You see that there are slight differences between pre-harvest and harvest. Please consider that here we consider periods ranging from 12 to 15 days in between the two moments. Some things are totally random, unpredictable. Other situations are less unexpected. For example, pyridoxine has a typical behavior that we can expect, while nicotinamide pantothenic acid has the opposite type of behavior. Here we contrast and compare the 3 years. And again, it is the analysis of the MAST. We did not detect major differences, but nicotinic acid went down from year to year. It was balanced, though, by nicotinamide. And then we also have other values which are of interest, but let's say no major differences. The same analysis is made for amino acids. Again, in MASTs of the pre-harvest moment and then the harvest, also with a view to assess what might happen at fermentation. Many of them amino acids have an impact on the growth of the yeast, and we have all the amino acids that are rapidly absorbed by yeast, and that should be considered to be preferential for growth at least. And then all the amino acids that have a repercussion as leucine, valine, isoleucine, phenylalanine, and so on and so forth, that have an impact in the production of acetates and higher alcohols. We also then analyze the amino acidic composition of the MAST, and we can compare and contrast what happened in that interval from pre-harvest to harvest. This tells us about the development. For instance, ammonium goes down and amino acids increase. And that is one thing. Plus, we understand whether there are significant differences in different years, and we see whether that has an impact on fermentation or on acetic acid and other basic parameters of wine. So we consider amino acids as elements which contribute to the aromatic component of wine. Examples. Top left, you see a graph where you have amino acids in the A group at pre-harvest and the same ones at harvest. There is an increase in general. There are years in which the single group of amino acids increases by 1.5 times, and in other cases it is a twofold increase, and the same goes for aromatic amino acids. There are years in which from pre-harvest to harvest and I will show you data about that. There is a 1.5 increase. In other cases, there is a 3.5 increase. As Paolo said, we should know that, and we should know that there are things that are unforeseeable, things that we should measure and experiment.
Here you have fermentation charts created with MASUT before the harvest in micro samples at the lab. You see, before the harvest and during harvest, we allowed the inoculations to work slowly. We used a yeast called Micofirm of the quartz collection, plus several different types of nutrition depending on what we had decided to do. With grapes collected at the time of the general harvest, we tested Micofirm collection for quartz, against other strains. So there are no deviations in the olfactory perceptions in all the tests. But what matters is that each individual sample or each individual combination, yeast or nutrition in terms of nano-vinification, is clearly distinguishable. So here you see a few parameters we obtained with the MASUT of the harvest, where we compared the lab readings with the cellar readings. And bear in mind that we're talking about 350 milliliter bottles versus tanks of several dozen hectoliters. You see, the differences are not so important in glycerol and malic acid. Also, there are differences in acetic acid. The lab yeast does better than the cellar yeast, and that is systematic for all yeasts, but the differences are not so wide. And so that was surprising to us. But that shows that the nano-vinifications were proved pretty useful in profiling what then happened in the cellar. Here you also have the MASUT obtained from the harvest of 2020 and the comparison between the lab and the cellar in terms of volatile compounds, higher alcohols, short-chain fatty acids, acetate esters and ethyl esters. In some cases there are differences, in others none or close to none. This is 2021. The grapes were picked around the 27th of August for the pre-test, and then we changed 3 different nutritions. We started to apply the concept of the experimental design with the MASUT gathered during the general harvest on the 6th of September. We tested the conditions that had proved interesting pre-harvest, and then we compared what had happened in the microvinification tests in the lab with what had happened in the cellar. So there was a head-to-head comparison of microvinification with macrovinification. And here again, as you can see, the parameters of basic chemistry, ethanol, glycerol, malic, succinic, acetic, are all comparable. So that means that our small-scale model was sufficiently good in telling us what might have happened in the cellar. So also thinking of the tests carried in the lab versus what had happened in the cellar, it's still the same test, but with the use of a gas chromatographer. Now, the ethyl esters and fatty acids, short and medium chain, were a bit different. The rest is comparable. Now, what surprised us in this case, in terms of the differences being more significant, had to do with the 3 main THiols that we measure. In particular, the winery has a final content of 4 mmP that is much higher than the lab test, while hexanol is lower than in the lab, the 3 MHA. This is the 2022 harvest year. The grapes were picked and processed on the 24th of August. In this case, the yeast was quartzo against 3 other yeasts proposed by the cellar and another experimental yeast from us. and nutrition with CreaFirm, and the kinetics are all comparable. Ethanol is comparable. Here again, there were no major deviations from an olfactory perspective that were of any interest. But each condition, each sample, each yeast was clearly distinguishable, and that too was very important. So there was no standardization in the sensory aspects, but everything was clearly distinguishable. Here are the results in the lab tests among the various strains. You can see there are some differences in terms of acetic acid, especially the quartz against the resistant strain were very different. And here are the fermentation kinetics with the must obtained from the general harvest versus the pre-harvest must. The harvest must in just more than 1 week, 6 to 7 days, finished its fermentation, while the pre-harvest took 11 to 12 days to do the same. Here are the comparisons between the pre-harvest, lab harvest, and cellar harvest. Here the focus is mainly on the lab test during harvest versus the industrial test at the cellar. Glycerin is quite comparable. Acetic acid is comparable between harvest at the cellar and malic acid. There's a slight difference, and the same applies for succinic acid, but alcohol, glycerin, and acetic acid were entirely comparable. For the gas chromatography, higher alcohols were comparable. The lab tests and the industrial tests were different in terms of fatty acids, ethyl esters, and acetate esters. Lower results for the lab versus the cellar. For THiols, again, the cellar, as has been the case for the previous tests, gave results that were much higher for all three THiols, twice as big or 3 times as big as the lab data. So what can we say about these 3 years of experimentation using this approach? The model has shown good prospects for a mass profiling program. In other words, we have to keep profiling the mass not only via the analysis of technical maturity parameters, but going beyond, we are introducing the analysis of terpene and thiol precursors. So year after year, we are adding elements to mass profiling. The real-time monitoring system for kinetics in the lab proved to be precise, accurate, and repeatable. Microvinifications with pre-harvest mass did not show any kinetics problems. They all got to where they were supposed to, and there were no systematic or widespread organoleptic deviations or major problems. As I was saying before, wines made through microvinifications proved that the sensory characteristics were distinctive as a function of the various operating conditions that we had adopted. That was very important. And also importantly, the parameters of basic chemistry, if we compare the wines from the winery and those from the microvinifications, did not show any significant differences, because that means that the tool is sound, and it is a good way to predict what might have happened. I would like to thank Matteo, Martina, Edoardo, and Rabia for all the work, the good work that we've done. Thank you very much.
Buonasera a tutti, io sono Marco Roverso.
Good evening, everyone. I'm Marco Roverso. I'm a researcher at the Department of Chemical Science at the University of Padua. I'd like to thank everyone, first and foremost, Enoforum for organizing this event, Eva and Italiana Biotecnologie for giving us an opportunity to present this collaboration, this partnership. I will describe a minor part of the journey we have undertaken together in view of the development of analytical methodologies for wine applications. And of course, I am greeting you on behalf of the team at the Department of Chemical Sciences of my university. Now, I will suggest ideas and options, and I will concentrate very little on the actual figures and the results we have obtained, and my focus will be the workflow that we have implemented. Obviously, our group did not start researching into wine originally, but we developed an expertise in mass spectrometry. Why mass spectrometry? Because mass spectrometry is an analysis technique that makes it possible to obtain very selective information of any matters of interest, and if we wanted to say it more poetically, if we have to learn to listen to the wine or the yeast having a chat during fermentation, we needed to tune in on the right frequencies, and mass spectrometry is the tool to do that. Here you see equipment. The equipment that is available to our research group, because to obtain the information we need instruments, we need investments, we need people, we need knowledge. And all the knowledge and everything that is done also needs to be then transferred and applied to solve real-life problems. The analytical platforms that you see here make it possible to analyze a large number of compounds of analytes, to develop selective analytical methodologies on molecules that have very different physical and chemical properties, and also investigate very wide ranges of concentrations, very high and very low, and also to deal with complex matrices. And also we do not work only on wine, but we develop applications in various areas: environmental, pharmaceutical, clinic, and of course the food industry as well. How do we obtain information on the products of interest using this analysis? Well, mass spectrometry offers us a number of options. There are two types of approach. One is known as bottom-up and the other one is top-down. Starting from bottom-up, what mass spectrometry allows you to do in this respect, and especially the analytical techniques that are available to us, is a screening of the sample composition. In other words, fingerprinting. Not analyzing only specific analytes, but determine the molecular fingerprint of the sample. Understand what analytes and molecules exist in the sample, how they vary, how they're correlated, and their proportions. That also makes it possible to assess the analytical conditions which are necessary to derive this information. In other words, to work on the right frequencies to listen to tune in the right frequencies to analyze the sample. Now, on top of that, you also need a statistical processing and the optimization of other parameters, because the data we acquire is very complex and there is a huge mass of information. And therefore, to understand how our sample is composed and what are the interactions among the various components, we need to use statistical tools. Identifying the molecules that could be biomarkers of a given process, product, or environmental or growth conditions. From a non-target analysis, in other words, and that is not specific for specific compounds, we can move on to develop targeted analytical methods which are not necessarily based and grounded in mass spectrometry, but that could be expanded to other tools such as sensors and more cost-effective devices, be validated on a number of matrices, and then transfer the whole thing to protocols for the final user. The other approach is the top-down approach, which is also possible with the same type of equipment. It requires the development and optimization of methodologies for specific markers, a targeted analysis, in other words, with the obtention of target information and the qualification of specific analytes. Through these techniques, it is still possible to document the fingerprint of the sample and obtain semi-quantitative data on analytes that were not initially targets for the investigation, or it is possible to carry out retrospective analysis. In other words, a long time after the data was acquired, it is possible, I was saying, to obtain samples from data from the analyzed samples to quantify certain analytes that were not initially measured. Now, Italiana Tecnologie asked us a very specific question. They wanted to create markers for varietal thiols in wine. This has got to do with aromatic, with the chemistry of aromas. This is a challenging task. But the composition of these thiols and their relative composition certainly is important, because it all depends on the production process in question. And somehow it makes it possible to characterize the wine. And on top of monitoring all the production processes, it makes it possible to also customize the final product. The analysis of free thiols is certainly challenging, because you need to measure these very special molecules with special characteristics and features, and for them to be analyzed using conventional techniques and simple processes, you need to come to terms with the low concentrations at which they are displayed in the wines. These are also very reactive analytes. They are part of a complex matrix. Their molecular weight is low and their polarity is high. So that generally poses a problem for analytical purposes. Now, the work that our research group carried out, our research team carried out, consisted of developing approaches that could be more or less unusual to solve the problems connected with this type of analysis. For instance, for a high reactivity, it was necessary to stabilize the sample, because actually from a quantitative analysis, we wanted to measure the real quantity of thiols in the wine and not a content altered or biased because the sample was processed incorrectly. Now, obviously, there was an entire part consisting of the optimization of the extraction methods, because the concentrations are very low, and therefore at those concentrations they cannot be analyzed by any type of equipment. And the matrix was very complex as well, which required a validation of the methodology and its optimization on a matrix where the thiols were present at low concentrations alongside a number of other substances, of other compounds that were much more concentrated, which made the whole thing a lot more complicated. Additionally, we developed a method for these analytes so that we could also analyze them using more conventional and simpler techniques. Two methods were proposed. One was totally new, the reaction with iodacetamide, and another method that was then optimized using 4.4 deutopyridine. Now, for iodacetamide, here's the protocol we developed. Here you have the conditions. You have to work with an alkaline pH and a concentration of the derivatizing agent that was pretty high. Everything went well, but when we had to increase the volumes of samples to reach the necessary levels of concentration to provide answers, the analytical method showed some gaps, and it was abandoned, not because the conditions could not be further optimized, but because at some point the procedure was becoming excessively complex. At alkaline pH in wine, a number of compounds were precipitating, which had to be eliminated before the following analysis, and also the quantities, the amounts of reagents were high. So we decided to use the method already proposed in the literature, but the method had to be finally validated. Here are the conditions: 20 ml of sample, 200 nanoliters of dithioldipyridine, 20 milligrams of EDTA, 80 milliliters of acetaldehyde, 50%. Now, the complexity of the matrix was very high. These cartridges you see are generally used to treat 2-3 liters of water. In our case, they were necessary to treat 20 ml of wine. After the analysis, we continue with the validation of the methodology, initially without using any internal standards that would be marked because they would have been too costly. We compared a model wine prepared using the recipe and a mix of Trebbiano wine. We obtained very good results in terms of the analytical methodology, but we still had a big matrix effect. So the response of our THiols in real wine at equal concentrations was very different from the model wine. In this case, therefore, it was not possible to analyze different wine samples without using the matrix itself, and therefore it was not possible to do an external calibration. So it was proposed to also use 6MH, which is a thiol which is not present naturally in this wine, as an internal standard, but this too could not compensate not offset the matrix effect. So we decided to make an investment. We bought deuterated standards for some of the thiols that we were interested in, and that helped us solve most of the problems. In the end, the validation parameters were once again the right ones, the ones that we had been looking for. R2 was very good. The quantification, the measurement was being done correctly. Reproducibility was very good. You could get the limits of detection, 0.11 nanograms per liter, and the matrix effect had improved significantly. So it was possible also in very different wine samples to analyze. It was possible to analyze these analytes using an external calibration. The methodology was then transferred to Italiana Biotecnologie, to their instrument, which is different from ours. So the methodology was optimized. It was validated on their instrument, obtaining once again the necessary level of performance, and shortening by a lot the analysis time. In conclusion, also considering the needs of Italiana Biotecnologie, we developed a simple and fast methodology to prepare the sample to reach the limits of detection. We implemented the deuterated standards which were necessary to speed up the analysis, and very importantly, it was also possible to develop a final methodology which takes only 8 minutes. So this analysis was very fast, and that concludes my presentation. Thank you very much.
Buonasera a tutti, sarò velocissimo.
Good evening, everyone. I'll go very fast because I don't have much time on my hands. I'm not really a scientist in this team, so necessarily I'll give a very practical slant to my presentation. The main reason... Okay.
I will use
an excuse. Let me start again. Experiences and remarks after 3 years of predictive harvest. What was the goal at MASUT DA RIVE? The name is the name of the winery. The idea was that we should impart a consistent style to the wines that we were producing. The biggest problem we had to do with Sauvignon Blanc, as you all know. It is a pretty susceptible varietal that is sensitive to the vintage, where the ups and downs in style were most frequent. Not on Tokai Friulano, not on Chardonnay, but Sauvignon posed a problem. So we profiled the wines as you've been told. In the vintage years 2017, 18 and 19, part of them had already been bottled. We gave us 3-year goals. We carried out all the predictive analysis in 2019, 20 and 21 as illustrated before, to then come up with the ideal solutions for the company in question, MASUT DA RIVE. We wrote an article that was then published with lots of technical details, and if you're interested, we can send it to you. The goal was to improve the knowledge and know-how for the production of Sauvignon Blanc. Why? Well, because I think it's evident to everyone that the climate that we live in is changing, and so the rules that would apply 20 or 10 years ago no longer apply. So initially we had started measuring sugars to make a decision on harvest dates, because in the past all the grapes were raw, and making a wine of 12% alcohol by volume was a success. So then we started following the technological maturity, also taking care of acidity and pH, and that was an additional step. Nowadays, we've realized that that is no longer sufficient. I think it's stuff you know already. Otherwise, it would be too easy to maintain the same style year in, year out. It's true that every season is different. But all the parameters of technological maturity are parameters that are pretty easy to achieve. If I have to enrich, I can enrich. If I need to add or remove acidity, I can do that. It's a lot harder to take care of the aromatic precursors, which, however, in varietals like Sauvignon Blanc have a much higher incidence. And I can do close to nothing about that. I can change my way of cultivating the grapes, but I can't really do much. And actually, that is clearly visible here. You see that 2017, okay, in terms of 4-MMP, this was a parameter that the company liked, but we didn't know that this was the parameter we were interested in. We knew that 2017 was the vintage year when, first of all, the company identified with, in terms of style, they felt at the company, at the winery, that this was the best expression of their terroir. And then you have 2018 and 2019. We analyzed the main THiols that were composing our wines, and the big difference was indeed in terms of 4-MMP. With this information, we tried to enhance the perception of that particular compound. You can't do that unless you know, of course, the composition of your must. Because even in previous years, you could modify it, changing the parameters or trying to have the same technological parameters every year. But the differences were pretty big. So the only solution was to change the fermentation process, because that was the only aspect in which we had a say. So changing the yeasts and the yeast nutrition, that made it possible, as you can see here, to exalt this characteristic, which for that particular company, for the owners, for the market, for the area where the company was based, we felt was the best. Then for someone else, it might have been better to exalt another characteristic, but without the basic knowledge and without this predictive methodology, it would have been much harder for us to get there. Now, I'm a winemaker, and very selfishly, I'll say this: how do you get these results if they? We can't afford to wait 30 years to see what climate change is going to bring. And the companies that we work for can't afford to wait that long. So knowledge and an ability to anticipate the changes in the fermentation process. And of course, you can't know it entirely, because although by very little conditions in the winery, things change for the aromatic precursors and thiols. But having an accurate idea of my must composition and adapting one's vinification process in view of the result of the intended result is to me a great achievement, because we all are telling everybody that we are changing our vinification approach based on the harvest year. Now, if you're honest, I challenge you to say, I challenge you to say, if you really do that, do we really not do pumping overs if we feel we are extracting too much? No, but because we don't have enough knowledge with a predictive methodology, we know what will happen if we do or don't do certain things. So we have an option, we can choose. And that allows us to do things that were impossible before. Thank you.